Hello, my name is Zach Sullivan, and this is my video project 2. With Sullivan beginning with the letter S, I worked on problem 8, which was a relative and absolute extrema problem. So the first step in finding the relative extrema of a function is taking the derivative of the function. So here's our function. It is x squared times e to the x. So this is going to be product rule to find the derivative because it is the multiplication of two different functions. So here's our formula down here. I made x squared f of x and e to the x g of x. So first you're going to take the derivative of the first function, which is just going to be 2x because of power rule. It's really 2x to the 1, but you don't write the 1. And then you just plug in g of x, which is just e to the x, and then you add the derivative of the second function, which is also just e to the x because that's a basic derivative rule, and then you plug in your first function, which is just x squared. So here's what your final derivative will look like without the parentheses. I just put those in there to keep it organized. So the second step to finding your relative extrema is setting your derivative equal to 0 in solver to find your critical numbers. So your critical numbers are where your sign changes in the original function, so the peaks or valleys, and yeah, so that's what your critical numbers are. And then what to do with the critical numbers in step 3 is you create a sign chart. So you put your critical numbers in as your zeros, and then you put values in between your critical numbers to see what the sign of their output is to find your relative maxes. So here it's positive and then it changes to negative. That's going to look like that, which is a relative max. And then here it changes from negative to positive, which looks like that, and it's going to be a relative min. So with that, your relative max is at x equals -2, and your relative min is at x equals 0. Also, to find your output, to find the sign of your output, you plug those numbers into your derivative. But for the absolute extrema on the interval, from -1 to 4, you plug your values into the original function to get your outputs. And then obviously your absolute max is going to be the largest output on the interval, and your absolute min is going to be the smallest output on your interval. So here our absolute max is going to be at 4,873.57, and then your absolute min is going to be at 0, 0, which was also the relative min. So that is how you find absolute and relative min for a function.